Here's another one. The limit as x approaches 4 of x squared equals 16. I want to prove that statement. And so to do that, again, I'm going to say, given any epsilon greater than 0, there is a delta greater than 0. So f of x, I don't want to write f of x, I want to write the function x squared minus the limit 16 is less than epsilon whenever 0 is less than x minus 4 is less than delta. Again, I want to start with this part. X squared minus 16 is less than epsilon. And I want to get to something that involves absolute value of x minus 4. So I'm going to take the x squared minus 16, and I notice that I can factor that into x plus 4 times x minus 4. And the absolute value of that's less than epsilon. And I can break this into the absolute value of x plus 4 times the absolute value of x minus 4 is less than epsilon. And now I see I've got the absolute value of x minus 4 that I wanted. I see I've got that part. I need to figure out what to do with this thing, at the absolute value of x plus 4. Okay, so let's go ahead and say we want delta to be no bigger than 1. Let's go ahead and say that. That means that x minus 4 is going to be less than 1. If that's the case, then that means that negative 1 is less than x minus 4 is less than positive 1. Go back to the first part of the first video, see how I did that. And then if I add 4 everywhere, I get that 3 is between x is between 3 and 5. So that means x is no bigger than 5. Okay, if x is no bigger than 5, then I could say that this x right here is no bigger than 5. So x plus 4 is going to be smaller than 5 plus 4, and the absolute value of that is 9. So I can say that x plus 4 times x minus 4 in absolute value is less than 9 times x minus 4 is less than epsilon. And then I can divide both sides of this by 9 and get the absolute value of x minus 4 is less than epsilon over 9. So I ran out of space to put my answer. I'm going to say let delta be epsilon over 9 or 1, whichever is smaller. So somebody comes and says, hey, I want an epsilon of 10. You would compare 10 over 9 and 1 is smaller. You'd say, I'll give you a delta of 1. Or if somebody says, I want an epsilon of 1, you compare 1 over 9 and 1 and choose the smaller one. Or if they want epsilon equal to 0.099, you can say, hey, how about delta of 0.011? Because that's 0.099 divided by that. So now if I want to prove that the limit of x squared is 16 as x approaches 4, from that scratch work that we just did, we had that delta is the smaller of the two numbers 1 and epsilon over 9. So for my proof, I can say, given any epsilon greater than 0, let delta be the smaller of the two numbers 1 and epsilon over 9. So when they give you an epsilon, you find out what epsilon over 9 is, and if it's bigger than 1, you take 1. If it's less than 1, you take epsilon over 9. Okay, so then for our proof, whenever 0 is less than the absolute value of x minus 4 is less than delta, we have our absolute value of our function, x squared minus 16, the limit value. That's the absolute value of x plus 4 times the absolute value of x minus 4. All right, if you remember here, since we have x minus 4 is less than delta, that means it's definitely less than 1, because I'm picking the smaller of the two numbers, which means that x minus 4 is between 1 and negative 1, which means that if I add 4 to every side, I get 3 is less than x is less than 5. And so if x is less than 5, x plus 4 is going to be less than 9. So over here, x plus 4 is less than 9. X minus 4 was less than delta, and delta is going to be the smaller of the numbers 1 and epsilon over 9, so I'll have epsilon over 9. I know it's definitely less than that because it's the smaller of the two. And then 9 times epsilon over 9 is equal to epsilon, so I have, just cleaning things up, the absolute value of x squared minus 16 is less than epsilon, which is what we were trying to prove.